Today we will study about Stokes formula. Stokes formula के बारे में आज हम पढ़ेंगे, डिटेल्स में पढ़ेंगे. Stokes formula क्या है, किस काम में आता है, okay, and how can we find out the coefficient of viscosity of a liquid. You know that coefficient of viscosity is actually it gives you the idea कि वो nature of liquid के बारे में idea देता है. So now today we will study about Stokes formula, correct? So what Stokes did actually, Stokes ने क्या किया, एक spherical ball का motion को study किया. किसके अंदर motion को study किया? एक fluid के अंदर. Fluid में भी, it may be air, it may be gas, it may be liquid. Okay. So for to understand, we will consider हम एक liquid के अंदर एक solid sphere को का vertical motion का study करेंगे. This motion was studied by Stokes. Stokes study करने से Stokes को क्या उसका findings क्या था? Stokes को लगा कि जब ये बॉल फ्लूइड के थ्रू गिरता तो ये बॉल को एक विस्कस फोर्स, एक फ्रिक्शनल फोर्स अपोजिट टू द मोशन ये स्फीयर फील करता है. ओके, दैट इज स्फीयर एक्सपीरियंस ए viscous force along opposite direction. Okay, opposite to the direction of motion. This is fluid friction. This is called viscosity. So let us suppose this viscous force is represented by F. Correct? So this viscous force is proportional to the size of the sphere. So he says that it is radius to the power A. I don't know whether it is A is 1, 2 or 3. 1 means periphery, okay, 2 means surface area, 3 means volume, okay, so you have to find out. So he understood that if higher is the radius, higher will be the viscous force experienced, okay. जितने बड़े sphere लोगे उतना ज़्यादा viscous force experience करेगा, okay. This viscous force is proportional to the velocity of this sphere through the liquid. If the sphere falls with a higher velocity, it will experience more viscous force, correct? So viscous force is proportional to velocity to the power b. Whether it is proportional to the square of velocity or linearly proportional or cube of velocity, we will have to derive, okay, using certain techniques called dimensional analysis technique. So we will see. And then he also said the type of fluid where this sphere is flowing, whether it is glycerin or alcohol or water, what type of fluid you have taken. So viscous force depends on that. So viscous force is proportional to type of nature of fluid represented by coefficient of viscosity eta to the power c. So now viscous force acting on this sphere depends on three factors. So if we combine all these three, what we get? The viscous force acting is proportional to radius to the power A, velocity to the power B, and eta to the power C. Okay. So to replace this proportionality sign, we use a constant B to the power B and eta to the power C. Now we have to find out the value of A, B and C. Okay, what we will do, we will use dimensional analysis method. What is dimensional analysis method? The dimension of left hand side should be equal to the dimension of right hand side. So what is force? Force is m into a, mass into acceleration, meter per second square, ml to the power minus 2. This is the dimension of force. K is a constant, dimensionless constant, it's the number, so we will not take dimension of this. R is radius, radius is measured by length, so length to the power A. V is the velocity, meter per second, L to the power minus 1 to the power B, correct? Eta is coefficient of viscosity. What is dimension of eta? While eta actually appeared in Newton's formula, F is equal to eta A du by dx. You remember this is Newton's formula. So eta was force into dx by area into du. Force is mlt to the power minus 2. Dx is L, area is L square, du is meter per second. Correct. So L square cancels. So m L to the power minus 1, t to the power minus 1. This is the dimension of coefficient of viscosity. So what we will do, we will write eta here. The dimension of eta as m L to the power minus 1, t to the power minus 1 to the power c. Okay. So here the dimension, the power of m is 1, power of L is 1. Okay. So m L t to the power minus 2 equal to, here m is appearing, m to the power c, correct? L to the power a, L to the power b, L to the power minus c. So L to the power a, okay, powers are added, L to the power b, L to the power minus c. You understood this part? Correct? अच्छा, अभी बाकी क्या रहा? Time. Time is t to the power minus 1. Here t to the power minus b, and here it is t to the power minus c. So if here mass is 1, power is 1, then here mass is power c, so c equal to 1. C is now 1. Now minus b minus c equal to, this is the power of t, here it is minus 2. So minus b minus c equal to minus 2. If c is 1, then b equal to how much? B is 1. Correct. And now L. A plus b minus c is what? L to the power 1. A plus b minus c is 1, equating the dimension of length. Okay. So you put the power b, value of b and c. B is 1, c is 1, a equal to 1, so a is also 1. So we find that a equal to 1, b equal to 1, c equal to 1. Correct? So in this formula we can replace ABC by simply 1, 1 and 1. So F equal to K R to the power 1, V to the power 1, eta to the power 1. This is called Stokes formula of viscosity. Okay. This is the viscous force acting on a sphere falling through a fluid. After doing several experiments, experimentally Stokes found, Stokes को पता चला कि ये जो K है, K का वैल्यू होता है 6 into pi. So it is now F equal to 6 pi R V into eta. So if अगर कोई तुमको पूछे कि भाई एक स्फीयर है, स्फीयर फ्लूइड के अंदर वर्टिकल मोशन अलोंग डाउनवर्ड डायरेक्शन ये गिर रहा है ये स्फीयर, तो उस स्फीयर को कितना विस्कस फोर्स काम करेगा उसके ऊपर? 6 pi R into V into eta. Correct? This is the Stokes formula. So we will write it here. F equal to 6 pi eta R into V. Now let us study how we can use this Stokes formula to find out the coefficient of viscosity of a fluid. Okay, we will consider a fluid here. अभी इस fluid का मुझे coefficient of viscosity निकालना है. Okay, तो इस ये fluid को consider करेंगे. Now मैं एक sphere का motion study करेंगे. ठीक है, now I will consider a sphere falling through this fluid. तो जब एक स्फीयर फ्लूइड के थ्रू गिरता है तो क्या क्या फोर्स काम करेगा? एक तो चूंकि वो नीचे की तरफ आ रहा है, इसका मतलब क्या है कि उस स्फीयर के ऊपर उसका ग्रेविटेशनल फोर्स यानी उसका वेट काम कर रहा है. ठीक है. अच्छा, उसके ऊपर और क्या काम करेगा? buoyancy force, this is the Archimedes force, you know. Buoyant force. What is buoyant force? The weight of equal volume of fluid. Okay, you know this Archimedes principle, no? So when you immerse something inside water, then the weight of that body appears to be less than the weight in air, and this difference in weight, the apparent weight, is equal to the weight of equal volume of water displaced or liquid displaced where you immerse that. So that is buoyant force. And now one more additional force you come to know through this chapter. वो क्या force है? Frictional force. That is called the viscous force. ठीक है? तो दो force ऊपर की तरफ लगेगा, एक force नीचे की तरफ लगेगा. So what is the resultant force? अभी resultant force निकालने के लिए क्या इसमें what is the technique? ये तीनों force लग रहा but body is falling towards downward direction. मतलब रिजल्टेंट फोर्स में इन दोनों फोर्स में से कौन ज्यादा डोमिनेंट है? दिस वेट इज मोर, सो द रिजल्टेंट फोर्स इक्वल टू, और ये क्या है? सब स्ट्रेट लाइन फोर्स है, एकदम 180 डिग्री में काम करने वाला फोर्स है. तो वेक्टर एडिशन, वेक्टर सब्सट्रैक्शन का कोई जरूरत नहीं है, डायरेक्टली प्लस माइनस करने से रिजल्टेंट आएगा. ओके, एक फोर्स नीचे तरफ, ओके, माइनस ये फोर्स बायोन फोर्स है, माइनस ये विस्कस फोर्स है. सो दिस इज द रिजल्टेंट फोर्स. ओके, नाउ इसमें देयर आर सर्टेन थिंग्स. सी, जैसे ये स्फीयर गिरने लगता है तो इसका वेलोसिटी बढ़ेगा, है ना? कोई बॉडी अगर अर्थ के ग्रेविटी की तरफ गिर रहा तो उसका वेलोसिटी बढ़ेगा. अभी वेलोसिटी बढ़ेगा, वेलोसिटी मींस विस्कस फोर्स मींस दिस पार्ट. अगर वेलोसिटी बढ़ेगा तो रिजल्टेंट क्या हो जाएगा? कम होते जाएगा, बिकॉज वेट से ज्यादा माइनस होते जाएगा. ठीक है, एक समय आएगा कि ये जो वेलोसिटी बढ़ते बढ़ते ऐसा हो जाएगा कि रिजल्टेंट को जीरो कर देगा. ओके, सी एज दिस स्फीयर इज फॉलिंग थ्रू दिस फ्लूइड, वेलोसिटी विल इंक्रीज. वेलोसिटी इंक्रीज होने से क्या होगा? W से F ज्यादा से ज्यादा F माइनस होगा, माइनस होते होते क्या हो जाएगा? रिएक्शन बिकम्स जीरो एट सम टाइम. If there is no reaction, this is resultant. If the resultant force is zero, there is no force. It means there will be no acceleration. Okay, and the body will fall with constant velocity. This is very, very important. As it falls through the fluid, its velocity increases. If the velocity increases, the resultant force will become zero after some time. And if there is no resultant force, there will be no acceleration. If there is no acceleration, then the body will fall with a constant velocity. This constant velocity is called terminal velocity. Okay, एक example देता हूँ मैं तुमको. जैसे वाटर ड्रॉपलेट, वाटर ड्रॉपलेट कितने आसमान में फॉर्म होता है और ये नीचे इतना आता है. सोचो, एक्सेलरेशन इज 9.8 मीटर पर सेकेंड स्क्वायर, मतलब एक सेकेंड में 9.8 मीटर पर सेकेंड उसका वेलोसिटी बढ़ता है एक सेकेंड में. तो अगर 4 सेकेंड के बाद आता उतना दूर से आएगा तो कितनी वेलोसिटी अटेंड कर देगा? 9.8 को अगर 10 मानते हो तो 10 40 मीटर पर सेकेंड हो जाएगा उसका. ठीक है, तो इट विल हिट यू लाइक ए बुलेट. बट ऐसा नहीं होता. क्यों? बिकॉज जैसे वो नीचे की तरफ आने लगता है तो विस्कस फोर्स उसका रिजल्टेंट फोर्स को कम कर देगा. रिजल्टेंट फोर्स कम होते हुए तो जीरो हो जाएगा, एंड दिस वाटर ड्रॉपलेट विल फॉलो विद कांस्टेंट वेलोसिटी. मींस बिफोर हिटिंग योर अम्ब्रेला, दिस रेन ड्रॉप विल अटेंड द टर्मिनल वेलोसिटी. इट विल फॉलो विद ए यूनिफॉर्म वेलोसिटी without any acceleration. Okay, so let us suppose at this juncture when this velocity is maximum, the resultant is zero. What is weight? Weight is mass into g. What is buoyant force? Buoyant force means the weight of equal volume of fluid. Okay, so if the sphere has a radius r, then 4/3 pi r cube is the volume. Okay, suppose density of this metal ball is sigma, so volume into density is mass. Density of not metal ball, density of the liquid. Okay, density of the liquid is buoyant force, so weight of equal volume of liquid. So if rho is the density of the fluid, then volume into density is mass of the fluid into g. This will be the buoyant force, and what will be the viscous force? 6 pi eta r v. Let me remove this. So it is 6 pi eta r into v. Okay, and what is mass? Mass of this, mass of the sphere is 4 by 3 pi r cube into density of the metal, density of the substance, sphere, into g. So this is wet, W, wet, this is buoyant force, this is viscous force. The resultant is 0. So in this equation you know everything. You know everything in this equation. You know the density of the sphere, you know the density of the liquid, you know the radius. Okay, so what is unknown here? Velocity also you can determine. I can tell you, suppose you start how to find out velocity. Take a big jar, okay, and you mark 3 equal spaced marking, okay, and you have to mark this, ऐसे जगह पे मार्क करो ताकि ये इधर आते आते टर्मिनल वेलोसिटी अटेन कर जाए. तो तुम 2 स्टॉपवॉच चालू रखो. जब यहाँ पर आया बॉल तो एक स्टॉपवॉच चालू करो. जैसे बॉल यहाँ पर आया फर्स्ट स्टॉपवॉच बंद करो, ठीक है. सेकंड स्टॉपवॉच चालू करो. जैसे यहाँ आएगा सेकंड स्टॉपवॉच को बंद करो, ठीक है. तो तुमको पता है कि ये डिस्टेंस इक्वल डिस्टेंस है. सो सपोज एस डिस्टेंस है तो 2s, और यहाँ से A से B तक आने में टाइम लगा t1, B से C तक आने में टाइम लगा t2. 2 स्टॉप वॉच जो तुम्हारे पास है उसे क्या पता चल जाएगा? दोनों का टाइम पता चल जाएगा. अगर तुमको लगता है कि A से B तक आने में जितना टाइम लग रहा है B से C तक आने में उतना ही लगभग टाइम लग रहा है, तो इसका मतलब है दिस स्फीयर हैज अटेन्ड द टर्मिनल वेलोसिटी. ठीक है. नाउ सो 2s by distance by time is equal to what? This is the velocity. तो देखो इस इक्वेशन में सब कुछ पता है, वेलोसिटी तक पता चल गया. क्या नहीं पता है? ईटा. तो you can find out the coefficient of viscosity by using this equation. Okay. Now let us simplify it. Take this one this side. 6 pi eta rv equal to, what is common here? 4 by 3 pi r cube. G is common, so sigma minus rho. So density of the sphere is more than the density of the liquid, that is why it is falling. Okay. Okay, pi can be cancelled out, one of the r cancel out, r square, 6, 2, 3, so eta equal to 2 by 3 into 3, 9, 2 by 9 v r square g sigma minus rho, correct? So eta equal to 2 by 9 r square into g sigma minus rho. So using this formula one can easily find out the coefficient of viscosity. Now there is a minor correction required in this formula, because when this formula is derived, it is assumed that the liquid is infinite extent. Okay, liquid is infinite extent, means this liquid will be displaced, collide with the wall of the container and then come back, there will be a turbulence. These things are not considered. Okay, so that is why a little bit formula correction is required here, and then we can find out this. Okay, a little bit correction is required in this formula, just to consider that the liquid is taken in a bounded container. Okay, so using that correction we make it we use a working formula for calculating the coefficient of viscosity. तो अभी हमने क्या देखा? अभी हमने देखा कि स्टोक्स फार्मूला क्या है, ठीक है. एंड स्टोक्स फार्मूला देखने के बाद हमने स्टोक्स फार्मूला का यूज किया. यूज करने के बाद हमको क्या पता चला?  कि कोएफिशिएंट ऑफ विस्कोसिटी, स्टोक्स फार्मूला का यूज क्या है? किसी भी लिक्विड का कोफिशिएंट ऑफ विस्कोसिटी को हम डिटरमाइन कर सकते हैं. ओके, सो जस्ट फॉर द सेक ऑफ ऑल we will go through the, this is what we have calculated. Come here. So this is what we have calculated, Stokes formula, and dimension analysis. This is the motion of the fluid, motion of the solid falling through it. 2-3 forces are okay acting on this sphere as long as it is in motion, correct? So this is what we have found out. This is the R is the resultant. Here R is the resultant, and resultant W minus B minus F. Okay, this is the resultant, and it becomes, resultant becomes 0 because velocity increases, and when it is 0 then the body falls with a constant velocity. This velocity is called terminal velocity. This is a very important term, so you should remember this. And then we derive the formula of eta. But since there were two assumptions, okay, and this is how we have calculated the velocity. We have taken a long tall jar and allowed the sphere to fall through, and there are 3 equispaced labels entered. Using 2 stopwatch you can find out the time taken by this liquid to fall through these labels, and the coefficient of viscosity is measured at a particular temperature. Okay, there is a temperature dependency. So that is why this thermometer is given. Okay, at a particular temperature, this is the coefficient of viscosity. And as I told you that a little bit formula correction is required. Why? Because this liquid is continuous. That was the assumption that the liquid is continuous. Using that assumption we derived this formula, but actually liquid is not continuous. We have taken in a limited wall, within bounded by the limited wall, that is wall of the container, and the liquid is infinite extent. So liquid is not even infinite extent, it is bounded. So just to consider these two factors, we have to apply a little bit formula. Okay, this after this correction it becomes the working formula for calculating coefficient of viscosity. So you understood it. Thank you very much. Next time we will do, what is our next chapter? Gravitation. So next video we will come up with the lecture on gravitation. So a very interesting video, don't miss it. Thank you very much.